Voila. So to put it a little bit into context, the world has a climate problem, and fortunately more and more countries are moving to deal with that problem. So around 70 to 80% of global CO2 emissions arise now in countries that have committed to net zero emissions by mid-century. And these net zero emissions are consistent with a 1.5 degree climate change future. Now, net zero means net zero in all sectors. It means net zero in power generation, but also net zero in the end-use sectors. And that also includes transport, and therefore that also includes shipping. The shipping sector is anyway undergoing significant changes in terms of its fuel use, as the polluting bunker fuel is being replaced either with diesel fuel or with LNG. So this is anyway a good moment to also revisit, can't we find solutions that are carbon-free. There is a lot of activity in this sector. I would say it's moving faster than some of the other transport sectors. And as IRENA, we also participate in the Getting to Zero Coalition for Shipping. That is one of these initiatives. We issued last week our World Energy Transitions Outlook. So our 1.5 degree scenario. And there are a number of, let's say, system level insights from that study that I want to bring into this discussion about shipping. First one is that we see a significant role for bioenergy and also for liquid biofuels in the future energy system. So according to our numbers, the share of bioenergy in primary energy could increase from around 12–13% today to 25% by 2050. And within that, around 7% of final energy would be liquid biofuels. So we see significant growth need for liquid biofuels going forward. But of course, there will be competition for biofuels, because you can use it in aviation, you can use it in trucks, you can use it for feedstocks, etc. So you need to think carefully, where do you apply that? Another option is the use of synthetic fuels, and that is also very relevant in the case of shipping, and we'll come to that in a moment. So there are a number of options on the table. Now, the shipping sector accounts for around 10 exajoules of final energy demand, as you can see on the lower graph here. And the activity level, and therefore also energy use, is projected to increase in a reference scenario with policies in place. In a 1.5 degree world, through efficiency measures, etc., probably we can have a slight decline despite the fact that the activity increases because of efficiency gains. But still, we're talking about 10 exajoules of final energy compared to a global final energy use of around 350 exajoules. So we're talking something in the order of 3%, and that is roughly also the share in CO2 emissions. Now, as I said, there's a number of clean shipping fuel options on the table. There is ammonia, green ammonia produced from renewable electricity in combination with electrolysis of water to give green hydrogen, and subsequently that is converted to green ammonia, or blue ammonia, so produced from natural gas with CCS. Then there is renewable methanol, again, either biomass-based, or there's another option, and you can also produce it from from hydrogen and from CO2, so as an e-fuel. There is other types of biofuels. I think later you'll hear a presentation on biomethane, biolng. So all of these options are currently being discussed, and there's quite a lot of criteria which can be used to pick the fuel. Cost, toxicity, standards, availability are some of them. I should also say that the discussion and the solutions for large ocean-going vessels are different from those for inland and coastal shipping and ferries. So for this latter category, shorter distances, hydrogen and batteries can be suitable solutions. But for the moment, these solutions are not suited for large, long-distance ocean-going vessels. In terms of direct renewable energy use, there is also some interesting development around wind-assisted propulsion systems. They are being deployed. They can reduce fuel demand 10–20%, but they cannot completely replace fuel use. So I said that there is significant development in this sector, and just recently the Getting to Zero Coalition called for 5% net zero fuel by 2030. We need to move quickly because the lifespan of these ships is quite long, in the order of many decades. So if we want to be net zero by 2050, we need to start using, bringing net zero vessels into the fleet from 2030 onward. So there's not that much time left. The options on the table, as said, I mean, there are three main options: biofuels, renewable methanol, and green ammonia. And I'll go through these three options individually in a moment. And as I said, the other aspect is that you have to look at it also from a systems perspective. So other sectors are competing for the same resources, which may limit availability or which may have an impact on price. So first on the biofuels, so there is it's relatively straightforward to use biodiesel or renewable diesel in conventional engines. Of course, the availability is there a limiting factor. We're talking either dedicated oilseed plantations, where the yield is not that high, or we are talking the use of residual cooking oils, where also availability is a limit. Then there are a number of other types of let's say liquid products, which can also be produced from lignocellulosic biomass, including residues. There is development in that area, and I will focus on one of them, which is methanol. So across the board, there's discussions about what is now exactly the greenhouse gas impact. It's illustrated in this graph on the right. There's quite a range of numbers out there. So you need to be careful that it's developed in a way that it indeed reduces CO2 emissions. Also, the economics is an issue. At the moment, the costs are higher than of conventional oil products. And it's not so clear how these costs will develop going forward. Now, let me focus on one interesting fuel, which is receiving a lot of attention, and that is methanol. So methanol is a chemical product which has grown significantly in recent years, its use to around 100 million tons per year. It's used in chemicals, but also increasingly as a fuel, especially in China. And methanol can be used also in ocean-going vessels. There is around 15 such vessels in operation, with more to come. Now, today, methanol is produced from natural gas and coal, but it can also be produced in a carbon-neutral way, either as biomethanol or as e-methanol. So for the biomethanol, there are a number of production routes. You can do gasification of municipal solid waste. You can produce it as byproduct using residues from pulping, or you can produce it from biomethane. In all of these areas, there is development. At the moment, it's roughly twice as expensive as conventional methanol, but expectation is that cost will come down with technology learning and scale. And we did a dedicated report on that. You can find it on our website. A second interesting idea is to use ammonia as a fuel. So ammonia is today a major chemical commodity with a production of around 200 million tons per year. Again, it's today produced from natural gas and coal, but you can also produce it in a carbon neutral way. So either by capturing the CO2 from, if you use natural gas and storing that, or by producing ammonia from green hydrogen. So the blue ammonia, there is around 5 million tons of CO2 capture from ammonia production worldwide. It's mainly used for EUR at the moment. You can also produce ammonia from green hydrogen, so that is an interesting new development. There has been an announcement of a megaton per year plant in Saudi Arabia. There's also two plants of around 300 kiloton per year under development in Chile, and various plants are under development in Australia. So there's a lot of interest in this. And at the moment, the costs are very much determined by the cost of green hydrogen. At the moment, it's still roughly twice as expensive as conventional ammonia, but as the cost of green hydrogen are falling, the cost of green ammonia will also fall. And a number of ammonia fuel ships are currently being built. There is considerable experience with ammonia tankers, so there's experience with ammonia in shipping, but not yet as a fuel, but that's clearly a trend. This is coming. And the driver here, so is the cost reduction for green hydrogen, which in turn again is driven by the cost reduction in renewable electricity. So expectation is that in the coming decade, these costs will drop to around $1.50 per kilo of hydrogen, maybe even lower. And at these cost levels, it's attractive to also produce green ammonia. So a lot of attention at the moment for this green hydrogen production. So one of the challenges is that both for methanol and for ammonia, in the molecule itself, you cannot see how it has been produced, whether it has been produced with significant CO2 emissions or whether it's a clean fuel. And therefore, there is a need, an urgent need, to develop also green commodity standards and certification systems now, so that the user of these fuels can be confident that it is indeed a clean fuel that is being used. Such systems are in place for renewable electricity. They are being developed at the moment for green hydrogen. but probably will also need such systems going further downstream into renewable methanol and into green ammonia. So this is also something we are currently working on at IRENA in the context of our collaborative framework on green hydrogen. So in conclusion, interesting developments, very interesting developments in terms of alternative shipping fuels. There is a limited number of alternatives for ocean-going vessels that clearly jump out. I've highlighted especially green ammonia and renewable methanol. In both areas, significant developments at the moment, and will be very interesting to see how this develops going forward. That concludes my remarks. Thank you very much.
Thank you, Dolf, very much for that broader introduction, giving us a view of the different range of possibilities that exist in terms of moving towards net zero. So now I would like to introduce Berit Hinneman of Maersk, who is the Senior Innovation Project Manager and who has a lot of experience on the technology side of shipping. And if I may quote from her, only by combining technical, commercial, and strategic efforts, we can create new solutions for decarbonization. So Berit, maybe you'd like to expand on that a little bit more for us now and tell us how Maersk is driving this movement forward. Thank you very much, Berit. I will give you the floor.
Yeah, thank you very much, Paul. And yeah, I hope everyone can see my screen. And so good morning and thanks for inviting me to this exciting event. And yeah, and I would like to continue in a sense where Dolf Giel left off and talk about Maersk's journey towards decarbonization and how we see the marine fuels of the future. So how do I? Yeah. So just a few words about Maersk. We are a global logistics company, end-to-end logistics company. I mean, we are yeah, most well known for our shipping line, but we do end-to-end logistics, and we enable our customers to trade and grow by transporting goods anywhere. So also, as Paul mentioned in his introduction, yeah, probably some of the morning coffee or different kinds of things that Maersk has transported. We have over 80,000 employees. We are present in more than 130 countries. And now turning to the decarbonization and to the shipping side of things, we have a fleet of more than 700 container vessels. And also some important numbers looking at the decarbonization challenge is that we use about 10 million tons of fuel oil per year to power our container vessels. And also our scope 1 CO2 emissions are 33.9 million tons of CO2 per year. So these are very sizable numbers, and they demonstrate the magnitude of the decarbonization challenge. So let me, yes, excuse me. Yeah, so first of all, a few words on how we see decarbonization, and we see it as a strategic imperative for Maersk as a company, because our customers, they need us to decarbonize their supply chain in order to uphold their global footprint. Also investors, financial institutions, they expect sustainability. And also, as Paul also mentioned in the very beginning, shipping accounts for a sizable number, 2.5 to 3% of global greenhouse gas emission. And so urgent change is needed. And also society expects us to act. So we must decarbonize our entire operations to meet our customers' expectations for a decarbonized supply chain. But also, if we don't do that, we will become irrelevant, I mean, to our customers. And we need to do it as fast as technically and commercially possible. And to this, 2 years ago, a little bit more than 2 years ago, in the end of 2018, we went out and stated our goal of having net carbon neutral operations in 2050. And I would just like to mention energy efficiency has been always a focus area of ours, where we have made some sizable progress. But of course, in order to go to truly net zero CO2 operations, we also need to transition to entirely new marine fuels. And this is also what we are focusing on, and what is the topic of today's session. So what are we doing in this arena? I mean, we are approaching this from different angles. We drive innovation in new fuels, which is what I'm going to talk about today. Also related to that, we need to design carbon neutral vessels and see how we can ensure the technical feasibility from the vessel side. Also, we need to build carbon neutral products for our customers. And here I would like to mention that we already have a carbon neutral shipping product, the eco delivery product, where we use biofuels in our fleet already today. And this is, of course, what we will build on, where we do see some uptake of this product, and which we will also develop coming forward. And we need to push for regulatory frameworks. I mean, this is a transition for the entire industry, and needs to be supported by the corresponding regulatory frameworks. So looking at the fuel side, I mean, just sort of to start with an overview, to transition away from fossil feedstocks. In terms of feedstocks, I mean, looking at renewables, it can come from either biomass or renewable electricity, or a combination of the two. And there, we have also, since our announcement of the net carbon neutral operations goal, we have done a lot of feasibility studies as to a lot of different fuels. And for container shipping, I mean, the fuels that we are focusing on right now is biodiesel, methanol, lignin fuels, and ammonia. And this is and these are also some of the fuels that were mentioned by Dolph Gielen in the previous talk that we find to be feasible. And what I would like to do is here to dive a little bit more into those fuels. Biodiesel, we are already using that today. And obviously a key advantage is, as it also has been mentioned already, it can be used as a drop-in fuel in existing vessels and engines. And we are actually already doing that today. The key limitations that we see with this fuel is the limited availability, and also competing demand from other industries. So to decarbonize our entire fleet, we need to look at other solutions as well. Another fuel that we are pursuing is methanol. I mean, where we are looking at both biomethanol and e-methanol. And the key advantage of that is that it is already in operation as marine fuels for several ships out there. And also an engine is available. And it is also liquid at normal condition, and there is a lot of experience from the handling of methanol from the methanol industry. And the key limitations we see here is, I mean, again, there can be some limitations in scaling it, because for biomethanol, biomass feedstock needs to be available, and for e-methanol, we need a biogenic CO2 source. So there also we are looking at what will be the availability of those fuels, also given that we and also shipping as a whole will need very large amounts. Then I would like to mention the lignin fuels, where we are also together with partners are developing lignin alcohol blends as fuels. And why we think these fuels are interesting is because they can be a very price competitive alternative, because they can be cheaper than methanol or alcohols as such, maybe almost on par with fossil fuels. Also, blending lignin in increases the energy density of the fuel, which is also a very good thing. And from our current knowledge, we foresee that the requirements for the engine will be similar as for methanol. However, these are still in development stage with production that still needs to be scaled up. And we also need to do some engine tests and see how to handle contaminants and so on. So we need to do some more technical developments there. We are also looking at ammonia, and here also especially at green ammonia, because it is a zero emissions fuel. And from the production side, obviously, the advantage is it can be produced at scale from renewable electricity alone. So in terms of scalability, it is very attractive. From the technical side, some more developments are needed before we can use it on container ships. The engine is not yet available. A two-stroke engine is being developed, but that will be several years before that engine will be available. Also, there are safety and toxicity challenges as to the handling of ammonia during onboard operations and also during bunkering. We believe that these can be solved, in collaboration across the industry, but some more work is needed to do that actually. So this is basically where we are in terms of the fuels, and we are pursuing several options because we do think optionality is important going forward. Yes, one point I would like to highlight, the transformation needs to happen across the entire fuel supply chain, from the feedstock through the production infrastructure fuel system on board. So we need to solve all the challenges along the entire chain in order to put it into operation. And also, we talk a lot about there's a lot of talk about the chicken and the egg challenge. Who moves first? Because in order to invest in ships, we need to be sure that the fuel is there, and also vice versa. In order to develop fuel projects, the offtake needs to be established. And the way we see it is that we see first mover action as a key enabler for actually solving this challenge. And to this end, maybe you have seen it a month ago, we announced that we will actually build the first carbon neutral container ship, and we will put it into operation in 2023, which is actually 7 years ahead of what we planned. And this is also very much in line with one of the points that was made by Dolph Gielen in the previous talk, is that to 2050, we don't have that much time, because the average lifetime of a container ship is about 20 years. And so we need to start to transition our fleet to carbon neutral operation, and we need to start that very soon. And this is also why we have announced this first carbon neutral liner vessel. And also we have announced that all future Maersk-owned new buildings, that they will have dual fuel technology installed for either carbon neutral operations or operations on very low sulfur fuel oil. And in general, 2 years ago, when we announced the carbon neutral target, it was a bit of a moonshot and we didn't know how to do it. Today, after these 2 years of work, we do see it as a very challenging target, but we also believe that we can actually achieve it, and we do see a path forward. So one point that I would like to make is these fuels, as also has been pointed out already, these fuels will be more expensive than fuel oil. And so we do depend on our customers to value carbon neutral transportation and also to pay for it. We have also reason to believe that that many of them will, because 90 of our top 200 customers, they have set or are in the process of setting ambitious decarbonization targets. And also, as you can see in the example on the right here, I mean, fuel costs will increase shipping rates, but if we do some sample calculations and say, what does that actually mean to the final customer product? Then, for example, a pair of running shoes, what the customer would have to pay more in the shop would be around 6 cents if they have been transported in a carbon neutral way. Or for example, for a computer, that would be around 60 cents. So to customer, the translation to customer prices shows that, that on the final product, it would be in the order of cents what this product, what carbon neutral transportation would add to it. So a little bit more detail on the first carbon neutral container ship. The ship will have a capacity of 2,000 TEU. The start of operations will be in 2023. The ship, I mean, as mentioned, will have a dual fuel engine. It will be able to operate on methanol and on very low sulfur fuel oil. And it will trade in one of our intra-regional networks. And we plan to operate this ship on carbon neutral e-methanol or sustainable biomethanol from day one. The challenge is that green methanol production is not yet there at scale. So we know that 2023 is ambitious, but we are doing our very best to secure green fuel. And also we hope and believe that this can kickstart the scaling of green methanol. And I would like to end by pointing out that collaboration across the industry is key in driving this forward. And we very much rely on collaboration across the board. I mean, with our customers, with the fuel manufacturers, technology partners, infrastructure partners, and so on. So with that, I would like to say, again, thank you very much for inviting me, and yeah, looking forward to the rest of the session and to answer any questions.
I do apologize. I didn't have my stick down, so you couldn't hear anything I said. So I'll recap. Thank you very much, Berit, very much for that very comprehensive resume of Maersk rollout programs towards net zero. And obviously, yes, we do have a question and answer session at the end, but I just want to pick on one thing very quickly before we pass over to the next speaker. Was a very important point you mentioned was on energy efficiency. And as we know, on land, equally the first place to start when we're looking at reducing our overall carbon footprint is energy efficiency. As in, on land, it's buildings, distribution, matching and optimizing energy of supply and demand, and in shipping also there are some key areas where energy efficiency in terms of, I understand, it's scheduling and route planning, but also I'm sure in the engineering of the boats there are areas where shipping energy efficiency is key as well. So that was important, and thank you for mentioning that. And you also touched on a variety of the fuels that and the biofuels that will which make up the mix of different sources for energy for shipping in the future, net zero energy for shipping in the future. And you also mentioned that some of them are obviously under development, that we're not quite there yet in terms of having all of them available. And this leads us on very nicely also to the next session, which is from a research institute in Finland, VTT, a well-renowned research institute across a range of technologies and subjects, but with a clear focus on renewable energy as well. And so it is my pleasure now to introduce Timo to you of VTT, who is a researcher and who is very involved in the BioFlex program, which is addressing this key issue of producing the new fuels of the future for net zero shipping. So Timo, with that introduction, I will pass.
Okay, thank you, Paul. It's a pleasure to be here, and thank you for the opportunity for presenting our BioFlex project. A very interesting presentation from Dolph and Berit. So I'm going to tell you from the research side what we are doing in Finland related to biofuel options for marine and power generation applications. So the BioFlex is about production of sustainable, storable liquid fuels for flexible power generation and marine transport. And okay, now I can change the slide for some reason. Sorry for that. I try to share the presentation again. Just a second. Okay, now it works. So, as we already heard, we have a big challenge to reduce the greenhouse gas emission in shipping, and then also in power generation with combustion engines. And there is a big need for flexible bioenergy to balance variable renewable energy produced with the solar panels, with wind turbines. When you don't have the solar or wind, you need a reliable way to power up the power grid, or have to power the power grid. Low sulfur fuels are needed, and we also need to demonstrate the applicability of biofuels for marine and stationary diesel engines for power generation. Partly that is already done with some applications, but there is still work to do. And what is maybe one disadvantage with the traditional biofuels is that the quality varies a lot, and therefore we see that there's a need for uniform quality biofuels. And how do we see the solutions for the challenges? We need to develop a concept for a stepwise approach for feasible and sustainable production of biomass and waste-derived liquid fuels for large engines. And we need to develop these liquid fuels with the good and uniform quality. And what is also important, what was mentioned by Dolph, that we need the specifications and standardization, and to create those, there needs to be a lot of data on the background. And what in our project, the benefits. So we are aiming for novel, flexible and feasible concept for sustainable production of adequate and uniform quality liquid fuels for diesel engines. I'm going to tell you shortly about the project structure. So we have a public research project, which is financed by Business Finland, which is an organization in Finnish government for funding a research project, for example. The public project is also financed by the companies participating to that, and also VTT, our research organization, and then the budget for the public research project is 1.6 million euros. On parallel with the public research project, we have company projects, and four of those, and there is the data in the company projects and the public projects. We share the data, and all the projects are related to each other. And what fields we are covering with our project? There's a lot of data in this slide, but I will concentrate on the work packages. The work package 1 is about finding the kind of feedstock for the liquefied intermediates, what could be used in the pyrolysis process, producing pyrolysis oil. And the work package 2 is then developing the upgrading process of these pyrolysis oils, increasing the quality of the oil so that it could be used with the engines. Then we have a work package for storage and quality. So we will do stability and storability, long-term tests. Of course, analyze the different fuels we are producing in this project, and also doing a research on mixing, how those fuels can be mixed, and can they be mixed with the fossil fuels. Then a separate work package for studying the standards and the norms and making background work for upcoming standards. On the work package 5, we do performance, cost, and sustainability analysis of the production process of these pyrolysis oils. Work package 6. I'm actually the leader of the work package 6, and it's the engine test. So the final product will be tested for performance and emissions with the actual engines. And then for disseminating the data and results we are gaining in this project, the network in IEA bioenergy will be used. And I would say our ambitious goal is to find the most ecologically and economically sustainable way to replace fossil heavy fuel oil in ship and power plant diesel engines. Like I said, it's an ambitious goal, and that also strongly supports the IMO's target for 2050. We have a quite good consortium in our project, and we cover multiple fields like the technology and machinery, supplies for feedstock liquefaction and upgrading. There's Valmet covering that. We have multiple fuel suppliers: Neste, Fortum, Polaratec, Pohjanmaan hyötyjätekuljetus, which is shipping ST1. Then of fuel supply system supplier Aura Marine, which manufactures fuel supply system for engine applications, and engine manufacturer Wärtsilä. And then which is shipping, which is a fuel supplier, but it's also an end user. They have a fleet of ships. And VTT's role in the research project is to provide impartial data on these different work packages that we are working on. And like already mentioned, we are using the networks we have with the IEA bioenergy. Some words about the fuels that we have planned for the engine measurements. Naturally, we need to have a fossil references, and we will have a one distillate quality and one residual quality as a reference. Then we have two types of pyrolysis oil. We have the upgraded hydrotreated fast pyrolysis oil and the upgraded catalytic pyrolysis oil. It is not sure that will this be used for all of the engine tests, but both are studied in the project. And then a Finnish company, Pohjanmaan Hyötyjätekuljetus, is producing pyrolysis liquid from plastics that will be used for the engine testing. And which is shipping has, or they're actually in the project, they're developing this high quality biofuel, which is, so to speak, kind of a traditional palm bio oil, but they're paying attention to the quality of the end product so that it would meet the engine manufacturer specifications. And we are going to use two different engines for the engine tests. We are doing a small scale testing with the 100 kilowatt turbocharged common rail on-road engine. This is for pre-testing the fuels, and for some fuels which are produced in the project, the availability is rather low. So we need to have a small engine to have a chance to test those fuels. And the final tests with the selected fuels, and there will be possibility also for fuel blends. We are doing with the Wärtsilä Vaasa 4R32 engine, which is a 4-cylinder engine, and the cylinder bore is 32 centimeters. The maximum power of the engine is 1.6 megawatts, and the RPMs are 750, which means that it's an intermediate speed engine. So basically, it's comparable to the 4-stroke ship engines which are used in overseas transportation. And for the large-scale engine testing, we will have a fuel supply system fully compatible with biofuels, and the system will be manufactured by Aura Marine, one of our project partners. And the measurements, what we are going to do, for sure, the engine performance, power output, cylinder pressure, fuel consumption. Cylinder pressure is very good way to see what happens with different fuels in the combustion, during the combustion. Multiple things can be calculated from that. We will do extensive emission measurements. We will cover gaseous emissions with so to say, with traditional analyzers and FTIR technology. We will measure the particle mass and the particle number, also the particle size distribution. Black carbon is very interesting for the marine industry. And we can also do multiple different analysis from the particle samples. For example, the organic and elemental carbon analysis and metal analysis. So summarizing, we have started the project in 2020. It will be finalized in 2023. And the goal is to find the most ecologically and economically sustainable way to replace fossil heavy fuel oil in ship and power plant diesel engines. And we will cover a full chain from feedstock studies to engine tests. and networking with the relevant partners from industry is and has been and is an important issue with this project. And you can follow the progress of the project in our website, and the results also will be exploited in various projects and networks. Okay, thank you for your attention. It was a pleasure to give this presentation.
Timo, many thanks indeed. Ambition, collaborative approach, plenty of high quality grey matter, government support, and strong methodology, all combining there, we can see, and we hope very much that success is the end result of all of that, and that you will achieve heavy duty oil as a bio oil, economically and ecologically achieving what you hope to on those 2 points, also achieving exactly what you're hoping to do. That would be fantastic, and we would really look forward to welcoming you back and developers of that BioFlex result in the future once you announce that you've achieved your results. That would be fantastic. So we wish you best of luck with that, and we'll no doubt there'll be a few more questions for you a little later on. Thank you. Thank you, Timo. So I'd now like to invite Johannes Schurman to take the microphone and to tell us, Johannes does this on a day-to-day basis. Good Fuels is one of the early movers in this arena of biofuels and biofuels for shipping. Johannes has the portfolio of looking to the future as well, innovation, and no doubt will provide us with perspectives of how biofuels in the future will look, and what Good Fuels is doing to move this whole biofuel subject forward for shipping. So Johannes, with that brief introduction, I will now pass the microphone.
Thank you, Paul. Let me share my screen. You can see my screen, I think. So good morning, everybody. My name is Johannes Schuurman. I'm the Innovation Manager of Good Fuels. For the people who don't know Good Fuels, we are a company that is a supplier of biofuels for the marine sector, and we are already doing that today. So we offer a solution for innovative, ambitious ship owners that want to decarbonize their fleet already today. So you have seen this graph before today already in the first presentation, I think also in the second presentation, but this graph shows the carbon emission from shipping. And you can see on the gray line starting in 1990 that the carbon emission are increasing from 500 million tons CO2 per year to today around now slightly below 1,000 million tons CO2 per year. And if you follow one of the blue lines which are different scenarios, you can see that without doing anything in the shipping industry, that the total carbon emission in shipping will increase quite fast. The IMO, the International Maritime Organization, they set a target for 2050 to reduce greenhouse gas emissions with 50% compared to 2008. So if you see the yellow dotted area, that's the area that we need to decrease in carbon emission in order to meet this quite ambitious target. So how can we do that? There are different options to do that. You can design your ship. You can, as Maersk told before, you can do quite a lot with fuel efficiency. You can optimize the shipping routes. But one option is also to use biofuels. You can see it in the bottom, the total potential of reducing CO2 emissions by biofuels can be up to 90%, or we have even seen it sometimes slightly above 90%, dependent on the feedstock and the logistics that you use during the production and transportation of the biofuels from the producer and to the vessels. So how will the shipping energy mix look like in 2050? This is a figure from a DNVGL report from 2018. And you can see that from the total share or the total fuel consumption in shipping, that carbon neutral fuels, which biofuels are part of, will account for around 39, or they estimate that it will account for 39% of all fuels used in shipping. If you look at short sea, this share is also 39%, but also electricity plays a larger role here, because short sea vessels can use electricity because they can plug in easier compared to deep sea vessels. And as you can see on the right, deep sea vessels almost don't use electricity. So what is important for these biofuels? There are basically 5 points that you should consider when bringing a biofuel on the market. The first is, of course, is it sustainable? So are you using a sustainable feedstock? There are multiple feedstocks out there that can be used. They range from waste oils, but also it could be palm oil, for example. And with the whole discussion around palm oil and the deforestation that comes with it, we at GioFlex, we don't use palm oil. We don't even use edible crops at the moment. We only use waste oils for the production of our biofuels. The second key point is, does it work? Does it work in a vessel? Can the current vessels that are out there use this fuel as a drop-in fuel? So they don't need, they should not need other component in their fuel system or in their storage to use this fuel. So it should really be a drop-in fuel. They should be able to use it today. The third point is it affordable? As we all know, the margins in shipping are really low, and fuel is one of the most important components in the business case of the shipping transportation companies. So the fuel should not be too expensive compared to fossil fuels. The fourth point is it available? Can we supply it already today? Or will it be available in 10, 20 years from now? So we are aiming to find fuels that are available today. The fifth point is it scalable? So if we do pilots with a new fuel, can we scale it up over time? So how did we start at GioFlex? GioFlex was founded in 2015 by a former, Dirk Kronemeyer is here still our founder, and he came from Sky Energy, which was founded in 2010. And at Sky Energy, he focused mainly on the development of aviation, sustainable fuels in aviation. And in 2015, he made the switch to GioFlex, where he found out that he wanted to focus more on shipping, because in shipping we can already do today something. Well, for aviation it's much harder to find and develop sustainable aviation fuels. So how did we start at GioFlex? The first time that we supplied a biofuel to the shipping was already back in 2015. Back then we supplied a 30% HVO blend to Boskalis, a Dutch dredging company. For the people who don't know HVO is also known as renewable diesel. Renewable diesel is already used in a 100% form in cars, also back in 2015. So we knew that it would work in an engine, although it was at that moment not tested in marine engines, and therefore we started also a testing program at one of the major engine manufacturers to do a pre-test on land with this product. The product complies with the EN 590 fuel standard, which is also the fuel standard for road applications. So because this product already works in cars, you can imagine that the quality must be quite high. But this quality was needed to get the marine sector confidence that they can use biofuels in shipping, because back then there were almost no companies that used biofuels in shipping. So we had to start somewhere. The fuel system on board of the vessels didn't need any adjustments, so they can just use it as a drop-in. So to come back with the 5 points, is it sustainable? Yes, it is sustainable. It was made from used cooking oil. It had a carbon reduction for at least the biogenic fraction of the product for around, I think, 80 or 90%, somewhere in between that. Did it work? Yes, it worked. Boskalis used HVO the last 5 years, and we are still supplying the product today to them, and not even in a 30% blend, but also in 100% form. Is it affordable? That's the big downside of HVO. Because of the high quality, it is also very expensive. And that's a major downside for the shipping sector. Therefore, we only supply this product to short sea vessels, inland vessels, port vessels, and not to the sea-going vessels anymore, because it's just much, much too expensive. Is it available? Yes, it is available at this moment. We can supply it wherever we want. Is it scalable? That is limited, and that is partly due to the fact that of the feedstocks that we use. So we only use waste oils, and the scalability of waste oils is limited. So I can imagine that at some point we need to investigate whether a dedicated fuel crops are needed, but for the moment our sustainability is limited. Criteria are limited to waste oils. So how to reduce this fuel cost? So back in 2017, as part of the Good Energy Group, which Good Fuels is also part of, the Good Shipping program was started. And in the Good Shipping program, we connect the cargo owners to the vessel owners. So if vessel owners are not able to pay the full price premium for the bioproduct compared to the fossil products, we find the cargo owners that might have their containers on board of that specific vessel, or have their containers on other container vessels, and we find them, the parties like IKEA, parties like Heineken, and we let them pay for the price premium, or at least part of the price premium, for the renewable fuels, for the biofuels. And therefore the vessel owners will have a lower price for their biofuels, and that can be an incentive for them to use biofuels instead of fossil fuels, as the high prices are not a major downside anymore. So does this product, this Good Shipping program, cover the full price premium? No, we also make use of an incentive system in the Netherlands, because for HVO, the price premium is just too big. But what we also did is that we thought, okay, in the fossil industry, the shipping sector is using residual products. They are using really the bottom of the barrel product from the fossil industry. And we can also do that with bio. So over time, we developed the Good Fuels MR100, the marine residual 100. This product is made out of residual streams from multiple biogenic processes. The product was launched in 2018, where we supplied this product to Norden, the North Highlander, as you can see on this picture. It was made out of, oh, sorry, there's something wrong in the presentation. It stated that it's a hydrotreated vegetable oil, but it isn't. It is a combination of residual oils. The fuel standard that it met was according to the parameters, the ISO 8217, although the ISO 8217 is a fossil fuel standard and it is not designed for biofuels. It also states that the product should be predominantly petroleum derived, which means that if the fuel is a biofuel, that it does not meet by definition this standard. But there are parameters in that standard, and we did meet the parameters of that standard. So that's also a thing that we should consider for the future, that there needs to come a biofuel standard in shipping. The feedstock that is used for this this product was used cooking oil as well. And what the vessels need to use this product is a HVO system. For the people who don't know the fuel system on board of a vessel, vessels have the capability to, or at least the vessels with HFO systems have the capability to store fuels heated on board of the vessel. This fuel has a pour point above 10 degrees Celsius, which means that in very cold areas it needs heating in order to stay liquid. Also on board you have a separator and filters, and those are also needed to purify the product. In the engine, the product works very well. Some vessels have run for more than 4,000 hours on this product for 100% without any engine problems during this trial period. So, is it sustainable? Yes, it is sustainable. Does it work? Yes, it does work. Is it affordable? It is much more affordable than HVO. Is it available? Yes, but it is still a niche product, and we as GioFlex supply it as the only supplier around the world. As far as I know, we are almost the only one supplying a bioresidual oil in a 100% form. Is it scalable? Because it is made out of waste oils, the scalability is also limited. Examples of customers. Yeah, you can see here a lot of customers. So the dredging companies, you can see the port vessels, a lot of cargo, so container liners, bulk liners. You can see here, for example, the heavy lifting and the Dutch marine vessels. So here you can see our current product portfolio. We are supplying, or we aim to supply all our products and in 100% bio form, but not all our customers want to use 100% bio at the first time. So often, or when our customers don't want to use 100% bio at the first time, we supply blends, and these blends range from 30% bio up to 70% bio, something like that, in order to make them confident that the product will work in their vessels. So I just showed you the fuels that we are currently supplying, but we are also in the development of future fuels because we want to be, we want to know which fuels will be, that we can supply in the near future. So in the previous presentation, you heard about, for example, fast pyrolysis bio oil. We are also in a project together with the Dutch company Biomass Technology Group, which already produces pyrolysis oil in the Netherlands and also in Finland. We are in a project where we're looking at the upgrading of this fast pyrolysis oil into a marine fuel. We are also in a project which is Horizon 2020 funded, which is called Next Gen Road Fuels, and we are exploring hydrothermal liquefaction fuels made out of sewage sludge. In a music project, we are also looking at pyrolysis oil and the upgrading of that. In the Ideal Fuel project, we are looking at lignin fuels, just like Maersk said in the second presentation. And in the Biosfera project, We are looking at solvolysis of lignocellulosic feedstocks, which can also be categorized as lignin fuels. So we are in a lot of development projects where we look at the future fuels. So how do we determine whether a fuel works or not? First of all, we start looking at the sustainability, because that's the core thing. We can develop fuels that are not sustainable, but that would not make sense. So we start with looking at the sustainability. Then we look at the biofuel analysis. So how does the biofuel look like? Can it work? Does it meet the requirements of a vessel? Then we look at the compatibility and blending, because the fuels that we will supply to vessels will be in contact with the fossil fuels or with our other biofuels. So that should not lead to compatibility problems. Then we do engine testing. So we are in contact with all major engine manufacturers, but also doing live tests on board of vessels. And that's basically the phase that we are in now, in phase 4 with our current fuels. We are doing the fuels that we supply them for many, many years now. But it is still a proof of concept phase, because there is no fuel standard yet. So we need to prove the sector and the IMO and the ISO standardization organization that such products work. And we aim to do that, to get a OEM approval at some point. And that's the next step for us. And after that, fuel sales can increase quite rapidly. And we make the pathway for other fuel suppliers and ambitious, innovative shipping companies as well. This was basically my presentation. Thank you all. And of course, I'm open for questions.
Thank you, Johannes, very much. Thank you very much indeed. Showing us your commitment to sustainable biofuels goes back a number of years, but also very interestingly showing the future as you envisage it. And I think to see also how you mirror a little bit VTT, in the sense that VTT as a technology provider reaching out across the board, collaborating with other organizations to bring together combined expertise. In the same way, it's interesting to see you as a fuel supplier reaching out to new technology providers and looking to see how you can combine together to broaden your offer in terms of sustainable biofuels from new sources and new feedstocks. So it's interesting to see how that collaboration approach you taking matches also VTT, and exactly what Berit was also stating in her presentation from the MESS point of view, that this is key to all of this coming together is collaboration. Yeah. So that's interesting to see that you're mirroring that in actually what you're doing. All of you are mirroring that principle. And leading on from that, a question to you all, if I may, because I think everybody has, everybody has now put their microphones back on. This key question of collaboration, to what extent do you feel it's where it needs to be? Because as we all know, there's a chain involved here, and a chain is made up of different links. And in order for that entire chain to continue to function, the collaboration has to involve all parts of the link, of all links in that chain. And so we see things like the IMO is driving very strongly for reducing, for decarbonizing shipping. We see initiatives such as the WPSP for ports trying to combine their knowledge and their approach to infrastructure. Where would you see the need to strengthen this collectiveness in order to really achieve a net zero shipping in the future? Where would you see you need to accentuate that collaboration, if anywhere? But maybe you're going to say it's all perfect and everybody's working exactly on the same path, but maybe there are areas that you need to strengthen on that. So would anybody like to pick up on that? Dolph, maybe you would like to, with your panoramic view of the whole sector, maybe you'd like to respond to that, please.
Well, I already mentioned this getting to zero coalition, where you see that it's fuel suppliers, ship owners, it's also the customers and others participating in that discussion. So yeah, I find that a pretty complete discussion. As long as that's not clear, it's a bit difficult to have, let's say, a clear single direction to adhere to, as you also saw in the other presentations.
Would anybody else like to respond to the question of our panel?
Yeah, I would say that consistent policy support is very important at this moment. So as Marst mentioned in her presentation, a vessel will sail for 20 years. So the new built vessels now will sail for 20 years. And if a shipping company needs to decide which type of engine they will put in their vessel, then it needs to be clear what type of fuels will be supported for the next decades, and not for just for the next couple of years, but for the next decades.
I would actually like to make a couple of comments here as well. Yeah, I mean, first of all, I'd like to, can you hear me? Okay.
Yes, we can hear.
Super. Yes, I wasn't sure. Yeah. Anyway, first of all, I would like to comment on what Dolph was saying, that it's not yet clear whether there will be one solution in the future or whether there will be several solutions in the future. And we agree with that. I mean, we see that there may as well be several, and therefore it is important to pursue several solutions. Also, I'd like to echo the point on the policy support, and also the point on saying that we need to start the transition with the vessel lifetimes being as long as they are. And it is an industry transition where there needs to be a level playing field, and where we also need to work together with our customers, because we do depend on, I mean, either policy support, or we depend on that our customers value carbon neutral transportation.
Okay, thank you, Berit. You're a panel with ESP, because in fact you anticipated my next question, which was very much along the lines of, today we see a chicken with many eggs in the basket, and the question is, will there actually be one egg in the basket at the end? Do you think, as we have today, a one solution fits all? Will there be a one solution fits all in the future, or will we have a variety of options, and that will continue to provide the answers for achieving sustainable shipping?
Yeah, I mean, I can start by saying, I mean, maybe I'm probably repeating myself here, but we think there may be more than one solution. I mean, of course, we don't know that, but we do believe in the importance of developing more than one solution. I mean, to ensure that there is optionality, and that there is a path forward towards carbon neutrality.
Perfect.
If I'm correct, the dual fuel engines that are developed now, they use, for example, methanol as a fuel, but they also need a pilot fuel. So they need a fuel together with methanol during the combustion. And that means that we cannot, at least for the near future, use methanol as a pure fuel. So it needs a biodiesel or a synthetic diesel at the same time during combustion.
Yes, I mean that is correct. I mean, that is the case for methanol. That is also expected to be the case for ammonia, actually. So So yes, so amounts of biofuels for this pilot fuel. I mean, this will be needed as well, which is not always taken into account, and the amounts vary. I mean, on the engine and technology, but it needs to be there. Yes.
Okay, well,
Oh,
Timo, did you want?
yeah, well, actually, I was also going to say that here at VTT at Finland, we also believe that there will be most likely multiple options for the for the fuels. It's difficult to see that there would be only one kind of a silver bullet, one solution.
Okay, well, thank you very much, everybody, for your sharing your viewpoints on that. We're moving towards the end of the session, so it's a wait and see situation. But the point is, more importantly, is that people are engaging with this process today and getting on with it, and taking action to decarbonize shipping. And we very much appreciate the viewpoints that you've expressed, and how you've explained to us what each of you is doing in this sense, and how you're all working together to achieve that. So thank you everybody for participating, for joining us for this session. And we're now going to break out, and we'll be back again for part 2, when we will go more into the gaseous side of things, and liquefaction of gaseous biofuels, and look a little bit more at infrastructure as well. So thank you very much indeed to all our panelists. Thank you for all you, the participants, and we really hope you've taken away some valuable points from this, and that you'll be coming back again in the future with new ways of helping to move shipping towards net zero, and that you all will be, as participants, will be participating in this movement. So thank you very much indeed again, and hopefully see you all back again in about half an hour's time. Thank you. Goodbye.
Thank you.
Thank you.
Thank you.